countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting Kitab for Muslim, or to the non-Muslim may pray according to your own region. Al-Fatiha. Let me introduce myself. I'm Cikgu Shahnon from Penang Matriculation College, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have teacher Vivi Lau from SMK Tinggi Klang. We are now live on Teachers Vivi Lau's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is periodic table, periodicity. And together with us, we also have Teacher Tang, who is control host in charge ensure the smoothness of our lesson on technical support. And last but not least, Cikgu Mawar as an observer. Okay, before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat session wisely. Number two, regarding certificate link, the link will be given at the end of our lesson. Please use EDD, MOE, My Guru, and My Jawi account when you fill in your particulars. Make sure you fill in the form within the time limit, which is 30 minutes. Okay, especially for a student, I announced the passcode of IU credit. For your information, the passcode will be announced 3 times, at the beginning, in the middle, and at the end of the broadcast. Our first code is letter A and number 2. I repeat, letter A and number 2. So without further ado, teachers Vivi Lau is welcome to present periodicity.
Okay, good evening, teacher and students. Today we were going to learn about periodicity. Can you see my slide? Okay, so first I will introduce myself. I'm teaching in SMK Tinggi Klang, and my channel, YouTube channel is Vivi Lau. Okay, then this is our PU teammate. First we have mathematics department, which is led by teacher Im, and biology.
Teacher Vivi Lau,
Yes.
We can see your slide moving, your slide.
Oh, okay. So
not
I
in the mood
share
of
again.
presentation, I think.
Okay, sorry. So I share again.
Okay, we're still waiting, teacher Vivi Lau, because maybe we have a little bit technical problem. By the way, periodic table actually is the topic that's very, very important to matriculation student and also for STPM student. Yeah, we still waiting. Teacher Tang, anything you can add?
Still waiting for teacher Vivi Lau. I think she might have
Mm-hmm.
some internet connections problem.
Yeah. Okay. Now I can see that teachers be
Oh yeah,
below. Okay. Now.
disappear from the.
Okay, you can share your PowerPoint.
Okay. Okay, so continue.
Okay. Now, yeah, that's good.
So
Okay.
this is PU Maths Department, Biology, Physics, and Accounts and Economy. And last but not least, Chemistry, which is led out by our KP Cikgu Shannon. Okay, so today we will learn about physical properties only. So for periodicity, we study the trend in the across the period. So the physical properties we are going to discuss is first atomic size, ionic size, then followed by electrical melting point, electrical conductivity, ionization energy. Okay, so so generally across the period, for based on the diagram here, ionization energy increase, electron affinity increase. So across the period, non-metallic character increase, so metallic character decrease, and the atomic size decrease. Okay, so these are the properties for period 2. Okay, then we have we focus first. We look at atomic size. So across the period, the atomic size decreasing. Okay, so for this period 3, so the atomic size generally decrease from sodium to chlorine. Okay, so atomic size is the distance, average distance between the two covalently bonded atoms. Okay, so if it's a covalent bonded molecules, so atomic size is 1/2 of the average distance between the two covalently bonded atoms. Okay, so equal to d/2. Okay, distance between the nuclei then divided by half 2. Okay. Okay, so factors affecting the atomic release, effective nuclear charge and the sealing effect. So the formula for effective nuclear charge is a nuclear charge minus the number of inner electrons, okay, or sealing effect here. Okay, so we get the net charge, which is called effective nuclear charge. Then sealing effect, also called as screening effect, is the inner electron repulsion experienced by the valence electron. So you look at the this picture. So nuclear charge is the charge of the nucleus, the proton number. So the proton has positive charge. Then in the nucleus we also have neutron, but neutron does not have charge. So across the period, the proton number increase. Proton number or atomic number increase. The nuclear charge increase also. Okay, then effective nuclear charge is consider the nuclear charge minus the sealing effect in a number of inertial electron. Okay, so sealing effect is because of the repulsion between the inner electron. Okay, then experienced by the valence electron. Okay, so the sealing effect or screening effect protect the valence electron from the attraction of nucleus. Okay, so in period 2 and 3, the atomic size decreases steadily as atomic number or proton number increases. So the nuclear charge increase, screening effect remains almost the same because the electrons are added to the same cell. Okay, so the same cell electron will not seal each other more effectively. Okay, and the number of inner cells are the same, same number of inner cells. Therefore, the attraction for the valence electron increases and the atomic size decreases. Okay, effective nuclear charge increases. So the attraction increases, atomic size decreases. And so the graph here show the important points. So across a period, okay, the nuclear charge increase, number of inner shell electron remain constant, so effective nuclear charge increase. So stronger attraction, smaller atomic size. Then going down the group, okay, going down the same group, the atoms getting bigger, okay, because the element under each one has the extra full cell of electron. Okay, so the valence electron not only further but also have better screening by the more inner shell electrons. Okay, screening effect increase. So the effective nuclear charge decreases. So the valence electron are not held so tightly by the nucleus, and the atomic size increases. Okay, so this is the key point. Okay, so additional going down the group, additional inner orbitals. Okay, screening effect increase, so weaker attraction and atomic size increase. Okay, so the one is atomic size. Now we look at ionic size. So ions form when the metal donate electron. Okay, so after donate electron, so the ion form will have less one cell from compared to the metal. Okay, so the size smaller for the ion compared to the neutral element. Then for negative ion, they accept electron. So the negative ion is larger than the element. Okay, so across the period, the ionic size also decreasing. But we have a big difference between the K ion and the negative ion in the same period. So the N negative ion have bigger size compared to the K ions. Okay, so you can see from here the negative ion has extra inner shell. Okay, so it will have bigger size. Okay, then we have isoelectronic species. Isoelectronic species means atoms or ion with the same electronic configuration. They have same number of electrons. So the ionic radius decrease from the oxygen to the aluminum. Okay, refer to this one. Okay, so this one isoelectronic ions. Okay, so the K ion have the same number of electron 10, then the N ion have the same number of electron 18. So the electronic configuration for the K ion is 1s2, 2s2, 2p6, and the N ion is 1s2, 2s2, 2p6, 3s2, and 3p6. And the explanation for the ions, okay, across the period from sodium to aluminum, the ionic size decrease, okay, when they have same number of electrons, but the number of proton increases, okay, so nuclear charge increases, and across the period, the screening effect remains the same because they have same number of cell of electrons, and hence the effective nuclear charge increases, so the ionic size decreases. So same like the atomic size explanation. Okay, then for the negative ion, similar things happen. Across the period, okay, from phosphorus to chlorine, nuclear charge increases, okay, and screening effect increases, so the attraction become weaker, okay. So ionic size decreases from the phosphorus to chloride ion. So same explanation. Okay, now we look at the question number 1. Okay, so list the following atoms in order of increasing atomic size. So you can write your answer in the chat box. So increasing atomic size. So you check whether they are in the same period. Okay.
Our student too
Answer.
shy, teacher Vivi Lau.
Oh, got
Our
answer. Right?
student too shy. Maybe you can give your answer.
Can write your answer in the chat box. Okay, any answer?
No.
So first you see whether they are in the same period. Okay. So if the same period across the period will be atomic size decreases. If got same different period, so means going down the group, the atomic size increases. So have answer. Cikgu Shannon.
No. Maybe you can just give the answer.
Okay, so I give the answer. So lithium and neon are the same period, period 2. So across the period, size decreases. So neon will be the smallest, followed by lithium. Then chlorine silicon miniature is the another period, period 3. Okay, so across the period, the size decreases. So chlorine has a smaller size compared to the silicon and magnesium. Okay. And question 2, choose a larger atom or ion in each pair. So you can write the large one in the check box. The larger one, larger atom or ion in the check box. Okay, any answer?
No.
So I give the answer.
Yeah, Z Chinchay.
What
Okay.
answer?
So we got a one answer from, let me.
What's the
Okay,
answer?
Z Chinchay.
Uh,
F minus,
okay,
CL
correct.
minus, NA
Correct.
plus.
Okay. NA plus. So NA plus wrong. Should be NA. The
Yeah,
KU
should
will
be
become
NA.
smaller. Okay. So the other answer correct. Okay. So folate ion correct. Folate ion bigger than argon. Okay. Then the third one should be because choose a larger one, so you have to choose sodium metal. Okay. So the sodium. So next we look at melting point. So these are the graph of the melting point and boiling point for period 2 and 3. So we look at the value. Okay. So from for period 2, carbon has the highest melting point. Then period 3, silicon highest. Okay. Then for metal, the melting point increasing across the metal. Okay. Then the non-metals, okay, non-metals have lower melting point. Okay, you can see they have the structure. So for the metal and carbon, they have giant structure. Okay, so metal is giant metallic structure, carbon is a giant covalent structure, silicon also. Then the non-metals like nitrogen, oxygen, they have simple covalent molecule structures. Okay, so this simple covalent molecules, they have low melting point because they have weak van der Waals forces. Okay, then the carbon, silicon, they have giant covalent molecule structure. Then the metals, they have metallic bond. Okay, so giant metallic structures. Okay, so this is the bonding in the metals are metallic bond. Then the bonding, this is a bonding you need to overcome for the uh, for the solid to melt. Okay, so for the giant covalent, you must break the covalent bonds. Then for the simple molecule, just need to overcome the weak van der Waals forces. That's why it has a lower melting point compared to the others. Okay, so these are the explanation. When you write the explanation, you say for the metals, they have strong metallic bonds. You must write strong metallic bonds between the atoms. So energy is required to break the strong metallic bonds between the metal atoms. Okay, then the melting point decreasing across the period, increasing across the period. Okay, because they are more localized electron. So the metallic bond increases. So melting point increases. Okay. Then the giant covalent molecule, silicon, okay, you have to break the covalent bonds between the silicon, okay, or carbon, for period 2, okay. So you have to break the strong covalent bonds between the atoms, okay. So for the weak van der Waals forces, you have to you need the energy to overcome the weak van der Waals forces between the molecules. Okay, so you have to write between the molecules or between the metal atoms or between the atoms in the giant covalent structure. Okay, so across the period from phosphorus to argon, okay, so sulfur has the highest melting point, okay, because of the largest molecular size, okay, followed by the phosphorus, chlorine, and argon. So the melting point of the sulfur also highest. Okay, then we look at melting point of oxides of period 3. Okay, so for oxides of period 3, So the magnesium oxide has the highest melting point. Okay. So this one is the melting point of oxide. So across a period, the melting point of oxide decreasing. Okay. Magnesium oxide higher than sodium oxide. Okay, so because of the magnesium oxide have more complex structure than sodium oxide. Okay, so here we have past year question. Discuss the melting point of the oxides. Okay, so determine the type of structures of aluminum oxide, silicon dioxide, and sulfur trioxide based on the value here. Okay, so aluminum oxide, what type of structure? You can type your answer in the chat box. Okay, any answer?
Maybe the question quite tough for them
Quite tough. Okay.
to answer.
So, so you have to determine the chemical structure and the bonding for the oxides.
Maybe you can give answer for question number 1,
Okay, so
aluminum
I give
oxide.
you the answer.
Mm.
Okay, so aluminum oxide is a ionic compound with covalent character. So this one you have learned in SEM 1, okay? The aluminum oxide, due to the high charge density of aluminum, so they have a covalent character in the oxide structure. Okay, although it's an ionic bond, but it has a covalent character because the high charge density of aluminum, it will attract the electron group of oxide ion. Okay, so they share electrons here, okay. So share electron here, so hence it has covalent character, so it will make the melting point higher compared to the magnesium and sodium. Okay. Then for SiO2 is a giant covalent. So this one, you know, okay, giant covalent molecule. So you need to break the strong covalent bonds between the atoms. Okay, so you will have high melting point also lah. Okay, sulfur trioxide is a simple covalent molecule. Okay, so you write simple covalent molecule. Okay, so it will have weak van der Waals forces. So here ask you to determine the type, so you no need to explain. So just write the structure. Okay. Then for the second one, you want to try? Melting point of magnesium oxide is higher than that of sodium oxide. But here got 2 marks. So you try to answer this one. You write the answer in the chat box also. Any answer?
Not yet.
Not yet. Okay, so I wait for a while. Okay, so maybe I share your answer. Huh? Okay. So no answer yet.
No.
Okay, so I share the answer. Okay,
Maybe you can
so
share your answer.
okay, so the answer, magnesium has higher charge than sodium. Okay, and the size is smaller, so it has high charge density. So it will have stronger ionic bond than the sodium oxide. Okay. So and
Okay,
more.
teacher Vivi Lau, let's stop for a while for advertisement. Okay, and then before that, I will announce the next passcode. The next passcode is number 7 and number 1. I repeat, number 7 and number 1. Okay, advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, students, let's continue our lesson with teacher Vivi Lau.
Okay, thank you, Cikgu Shannon. So we continue with electrical conductivity. So the graph here show the electrical conductivity across a period, okay, 2 and 3. So you can see we have for the metallic metals, they are conductor, okay. Then for the carbon, the graphite, semiconductor, silicon semiconductor. Then the non-metals are insulator. With insulator or non-conductor, okay. So we look at the period 2-1, okay. So in the period 3-1, okay. So across the period for the sodium, from sodium to aluminum, the conductivity increases, okay. Then going down at the semiconductor is silicon, and the non-metals, they are weak conductor or insulator. Okay, so the conductivity increase, okay, because they are both metal with strong metallic bond, so they are good conductor. Okay, then barium is better conductor than lithium because it has more valence electron. Barium has higher number of valence electron, so more valence electron to be relocalized and conduct electricity. Okay, then for the carbon, carbon have diamond and graphite allotropes. So diamond cannot conduct electricity. Then graphite is has a free relocalized electron to conduct electricity. Okay, so layer structure, the hexagonal layer got one pi electron, which is free to move and conduct the electricity. Okay, then boron is a semiconductor. Okay, it's a metalloid with small gaps between the valence band and conduction band, so it can conduct electricity. The conductivity can increase by increase the temperature or doping with other elements. For example, group 15 and group 13 elements. Okay, then non-metals, nitrogen, oxygen, fluorine, and neon, they are insulators, okay, because they have large gaps between the conduction band and valence band. Okay, same thing for period 3. Okay, then it's from sodium increase to aluminum, the conductivity, because of aluminum has the highest number of valence electron. Okay, then silicon, same like the boron, okay, also metalloid semiconductor. Okay, then phosphorus, sulfur, chlorine, argon, they are insulators. Okay, so we look at question 4. Okay, so you try to answer this question. So I read the question. Lithium, beryllium, magnesium, and silicon are elements in the periodic table. So which is the correct sequence according to the ascending order? So ascending order of electrical conductivities. So ascending order means increasing conductivity.
Maybe you can give more clue.
Okay, so just now from the graph just now, the metal is a good conductor, like then followed by semiconductor, and here don't have no metals.
Chia Ying, answer C.
Answer C. Any more answer?
Not yet. Is there any difference between period 2 and period 3? Period 2 and period 3. Any different?
Period 2 and period 3.
Z Chincai, D.
D.
Answer.
Okay, so if you look at the here,
Chia Ying also D.
So got 2 answer D, 1 answer C. Okay, so the correct answer is B. Okay, correct answer is B. Okay, so the
keyword here is ascending order, right? Ascending order.
orders. Okay, so beryllium has a highest electrical
From lower to
conductivity than
higher.
the magnesium. Okay, beryllium is smaller size. Okay.
If you look at the answer, lithium in period 2, magnesium in period 3, beryllium in period 2.
So beryllium higher than magnesium, followed by lithium, then silicon. Because silicon is a semiconductor, smaller size. So C and D cannot. Either A or B lah. Okay. Then beryllium conductivity higher because of the stronger metallic bond because smaller size. Okay.
Smaller size
Compared
than
to the smaller
magnesium.
size, stronger metallic bond. Okay, so answer B. C and D cannot because silicon semiconductors will be weaker conductivity than metal. Okay, then next we look at electronegativity. Electronegativity definition is the ability or power of the atom in the covalent bond to attract share electron to itself. So you don't confuse with electron affinity. Electron affinity is form negative ion. So electron affinity, the element accept electron and form negative ion. Then electron negativity is in the covalent bond. For example, hydrogen chloride. Okay, so chlorine has higher electron negativity than the hydrogen. So in the covalent bond, chlorine will attract more electron to itself. So make the chlorine more negative. Okay, so chlorine is partial negative here, then hydrogen partial positive. Okay, so the greater atom's electron negativity, greater ability to attract electron to itself. Okay, so chlorine has greater electron negativity. Okay, so electron negativity is shown in the Pauling scale. So here is the Pauling scale. So across a period, electron negativity increase because atomic size decrease, nuclear charge increase, and because same period, the number of inner shell of electron are the same, so no extra sealing effect. Then electronegativity decrease down the group because atomic size increase, nuclear charge increase, then sealing effect increase because it has extra shell of electron. The element below the each one will have extra shell of electron, so sealing effect increase. So effective nuclear charge increase, so electronegativity decrease. Okay, so fluorine has the highest electronegativity than the other members in the periodic table. Okay, so across the period increases. Okay, so there are electronegativity. Okay, now we look at ionization energy. So across the period, ionization energy increase. Then going down the group, the ionization energy decreasing. Okay, so we can use the ionization energy to predict the electronic structure, means the electronic configuration. So it show the evidence for shells. Okay, before that you must know the definition of first ionization energy. So this one you have learned in thermochemistry. So first ionization energy is the minimum energy required, okay, to remove one mole of electron from one mole of gaseous atom of element to form one mole of positive charge ion under standard condition. So example, we have sodium. So one mole of electron removed from one mole of sodium gaseous atom and form one mole of sodium ion. Then second ionization energy is the energy required. So it's same like first ionization energy, right? Only it removed from the positive charge ion. Okay, so remove from the positive charge ion and form library charge ion. Okay, so factors affect the magnitude of ionization energy. So atomic size, shielding effect. So overall is a effective nuclear charge. Okay, so larger atomic size will have weaker attraction between the nucleus and valence electron, so it will have low ionization energy. That's why going down the group, the atomic size increase, so ionization energy decrease. Then sealing effect, higher sealing effect will have weaker attraction between the nucleus and valence electron, so it will have lower ionization energy. Okay, so going down the group, okay, you have more sealing effect, more extra shell of electron. Okay, so higher sealing effect, so lower ionization energy. So effective nuclear charge, higher effective nuclear charge, stronger attraction between the nucleus and valence electron, so higher ionization energy. So going across the period, effective nuclear charge increase, atomic size decrease, nuclear charge increase, so effective nuclear charge increase, so stronger attraction between nucleus and valence electron, so across the period, higher ionization energy. Okay, so this one across the period, nuclear charge increase, proton number increase. Then screening effect almost the same. Okay, so effective nuclear charge increase, stronger attraction, atomic size decrease, more difficult to remove electrons, so first ionization energy increase. Okay, down the group because you have an additional inner shell electron. Screening effect increase, so weaker attraction, atomic size increase, so easier to remove valence electron. So first ionization energy decrease. Okay, so here show the graph. So generally increase. Okay, but we have some anomalous behavior. Barium higher than boron. Okay, nitrogen higher than oxygen. Okay, or magnesium higher than aluminum. Then phosphorus higher than sulfur. So this one you discuss using the electronic configuration. Okay. Okay, so the anomalous behavior, okay, between the group 2 and group 13. group 2 higher than 13, okay? Should be decreasing, right? It should be increasing, but 13 should be higher, but it's lower than group 2. So you can explain by the electronic configuration. So beryllium has a stable NS2 configuration. Okay, 2s2 configuration is more stable than the group 13 one, boron. Boron is 2s2 to p1. So it's partially filled, not less stable. So fully filled, more stable. So you need more energy to remove the electron from beryllium. So first ionization energy of beryllium is higher. Okay. Okay, then another anomalous behavior is between the group 15 and 16. Okay. So nitrogen has stable extra stability of half fill. Half fill P has extra stability. Okay, so partially filled not stable. So nitrogen has higher ionization energy than the oxygen. Oh, sorry, this one is not boron. Oxygen. Okay, oxygen. Okay, so same thing for the period 3. Okay, so this is a electronic configuration in box. Okay, box diagram. So same thing for period 3. Okay, so magnesium is stable 3s2. Okay, compared to this one 3s2 3p1. So this one more stable. So higher ionization energy. Then group 15 and group 16. Phosphorus is half fill extra stability. Okay, so 3p3 half fill more stable compared to the sulfur one. Okay, so this one partially feel less stable. Okay, so here is the explanation. So across the period, the ionization energy increases, but discontinuity, okay, because of the stability of full S subcell of magnesium. Then aluminum is the stability of the half fill. Sorry, magnesium aluminum is partially filled. Okay, so less stable. Another explanation is electron is removed from aluminum, which is higher energy orbital, so easier to remove. Okay, then between the phosphorus and sulfur, phosphorus is half fill extra stability, 3s2 3p3. Another explanation for sulfur is because of the repulsion of the 3p4, 3s2 3p4. So got repulsion here. This one got repulsion. Okay, so easier to remove. Okay. Okay, so going down the group, the ionization energy. This one is a successive ionization energy. This one is the table to show the successive ionization energy. So this one we will discuss how to prove the how to predict the group number for the element. You can determine from the successive ionization energy. Okay. So the successive ionization energy increasing. Okay, for element because repulsion among the remaining electrons decreases, so the electron can remove easily. Okay, the remaining electrons are closer to the nucleus and being pulled towards the positive charge nucleus. Attraction between the nucleus and valence electron becomes stronger, so more energy is required to remove the subsequent electrons, such as the second, third electron from the positive charge ion. So successive ionization energy of element increases. Okay. So we can use the successive ionization energy to show the electronic structure and the number of cells, okay, and also the electronic configuration of the element, okay. So so how to determine the electronic configuration from the successive ionization energy, okay? So we have to find the big jump between the successive ionization energy data, okay? So removal of that particular electron is from an inner shell, so means you need more energy to remove, okay? Which has a stable noble gas electronic configurations. Okay, then from the big jump here will show the number of valence electron. Okay, so we can use graph method, graph, or you table, you calculate the reference, okay. So for example, here we have element P and Q. Okay, so here I already show that here got a big increase between the number of fourth ionization energy and fifth ionization energy. We have a biggest difference. So means the fifth electron is removed from the inner shell. Okay, so we have 4 valence electron here. Okay, then second example we have Q. So here you have to minus each ionization energy, minus each subsequent ionization energy. So here I already show that between fifth and sixth ionization energy, we have a largest difference, biggest difference. Okay, so here show that the sixth electron removed is from the inner shell, more difficult to remove, right? Okay, so you have 5 valence electron. So this one 4 valence electron. So here 5 valence electron. So means this one is a group 14. Okay, then this one is group 15. Okay, so this is the you find the reference in value method. Okay, so because you don't know the period number, so your answer you will write valence electronic configuration and S2 and P2, so 4 valence electron. And for the Q1, the valence electronic configuration is 5 valence electron, so it's NS2 and P3. Okay, so this is a graph method. Okay, graph method, you plot the log 10 ionization energy against the number of electron removed. Okay, so you also find the large increase. After you plot the graph, you find the large increase. Okay, so you have 2 large increase here. So first one is between the first and second electron removed. Okay, so means the second electron removed from the inner shell. So you only have 1 valence electron. Okay, and between the 9 and 10, okay, 9 and 10 electron, so the 10 electron removed is from the another inner shell. Okay, so from here you can get the electronic configuration 2.8.1. Okay, so this one is electron arrangement, so the electronic configuration is 1s2, 2s2, 2p6, and 3s1. Okay, so two methods. Okay, so from the graph, you look for the significant increase. So first one is between first and second electron. Another large increase is between 9 and 10 electrons. Okay, so means the second and 10 from the inner shell, closer to nucleus. So you need more energy to remove. Okay, so we have a large increase to remove the second and 10 electron. Okay, so far any question? If not, we look at
No question. Yeah.
the question number 5. Okay, so you use your calculator, find the largest difference, biggest difference between the ionization energy. So, and after you find the largest difference, determine the group okay, of element X.
The clue is try to find the big jump,
The big jump, the largest difference.
the largest difference. 1,000, 2,000, 4,000, 7, 9, 53, 64.
So, cikgu Shana Oi, give a good. So, any answer?
Not yet.
Cikgu Shana Oi, give the answer.
Yeah, Z Jinchai. Group 15 because large increase between 5 and 6 ionization energy.
Okay, very good. So, group 15. Okay. So, 3 marks here. Right? So, group 15, 1 marks. Big difference between the fifth and sixth ionization energy, or you can say large increase in the sixth ionization energy. So, last point, last mark is 5 valence electron. Mention 5 valence electron. Okay. Any question? So we still have 3 minutes on. So we do one more question. Question 6. Okay. The properties of element can be deduced from electronic configuration. So which statement is true about sodium ion, chloride ion, argon atom, and potassium ion? Okay. The true statement. Okay. Any answer?
Not yet. Yeah, Z Jinchai, D.
Oh, okay. Very good.
The answer
So
is
the
D.
answer is D. Chloride ion, potassium ion, and argon have the same electronic configuration. Okay. So, any other question? I end
No.
the presentation here.
Okay.
Okay, thank you.
Alhamdulillah, we are done with today's lesson. We have learned a lot from teacher Vivi Lau about periodicity. Congratulations to those who are able to follow our lesson from the beginning till the end. And thank you very much, teacher Vivi Lau. Now it's time for me to announce the last passcode. The last passcode is number 1 and number 6. I repeat, number 1 and number 6. And the presenter telegram is t.me/chaiwi99. Okay. um, Once again, I would like to thank to Teacher Vilau for the interesting lesson. Thank you also to Cikgu Mawa and Teacher Tang for being with us today. I think that's all for now. See you in another lesson, another session. Please do remember stay at home and study. Goodbye, everyone. Have a nice weekend. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.